Boy, what a crazy storm that happened. I know a lot of places are closed, but a lot of schools didn't have class anyways today. They were off of, I don't know, midwinter break or something. We're going to talk about some things in chapter 3 today, but I'm going to start with the labs, just a review of the labs in chapter 2. Most people, well, I don't want to say most, people are either finishing those up or they have finished them up or they're stuck on them. So this is a good place to start. And when I say the labs, I just mean the green ones, the ones that were assigned, which are not all of them. So let me look. Chapter 2. What does that mean? Shown to students. Why are all these? I don't know why. Oh, there. Wait, I don't know why those are hidden. Okay, 13, 14, 15, and 16. So on chapter 2, the labs that are required. (13, 14, 15, and 16. And last week, I shared the solution for 216 in the announcements. So we won't cover that one. You can look at the announcements to check it out. I do have an error in it though. Hopefully you figured it out. I'll just show you real quick, but it's in the announcement. I put, for some reason, an SA at the end of one. Must have just been typing somewhere something else and it got over there. But 216 is using different lab functions. What I posted, it says SA right here. That's not part of the code. It's just a mistake. So take that off there and you should be good to go. So I'm not going to cover that one because I already shared the solution. All you guys working on 2 in the classroom, did you see that one? 216? All right, let's look at 212. I'm sorry, 213. That's the first one you need to do. I'm just going to go through these real quick because we're going to really focus on 3 today. This is a program that uses the floor division card. So it takes in 2 numbers, like a 2000 and then a number like 2. So it takes in a base number and then what you're dividing it by, a username and a division number. And then you're using the floor division operator to get an answer. The floor division operator is 2 division signs, and all it does is it truncates the decimal value. So it only looks at the whole part and not what's left over. So it's the opposite of the mod operator that we learned about in this chapter. The mod operator looks at what's remainder, and then the floor division looks at the whole number. So that's what 2 forward slashes mean. It's like 6 divided by 4 is 1.5. But if you do the 2 division signs, it just discards the half. 6 floor 2. So here we go. with the solution. If you need a screenshot, take it real quick. I am recording, so you can watch it later, but user num and division number are two inputs. So when you run the program, if we enter in 500 and then I want to divide that by 4, those are my two things. I'm going to first figure out the user num and divide and find the whole part of that. So I'll run my program. The first number that comes out is 125, and then I take 125 and divide by 4, and that's where I get 31. And then 31 divided by 4, and I get 7. Okay, so how that works is, pull up our calculator here. If I took in 500 and I divided by 4, well, I use the floor operator. There's no leftovers, so you get 125. Now I take 125 and I divide it by 4. I still have the same division number, and I get 31.25. And what comes out is your output is just 31, because we use the floor division and not the regular division. The regular division would have said 31.25. This one just shows you the whole number. And then, so the next one is 31 divided by 7, that is 4.42. Again, I'm sorry, not by 7, by 4. 31 divided by 4 gives us 7.75. Again, I only get 7 as my output over here because that 0.75 is discarded. So it wants you to, when you read this program, it says taking those two values 3 times using the floor division and display the answer. So that's all you have to do there. Any questions? Okay, the next one, just a recap of this is 214. This is a driving program. This is what we did do this one in class last week too, or the week before. This is a program that takes in how many miles and how many dollars, and then how much gas is. So like if your car gets 30 miles to the gallon and gas is $3.50, it takes in those two values. And then it figures out how much it costs after 20 miles, after 75, and after 500. And then it prints all 3 and it formats them 2 to the right of the decimal. So we use that printf format feature and then the :.2f. So screenshot if you want. This one we've covered and talked about enough. There's your formula. So I'm going to leave it right there. Did you get that one? All right. And then 215 is the last one. And then we'll look at chapter 3. 215, it's calories burned. I know I didn't, this one we talk about how you just kind of fill out the rest of everything, but I never really showed you the solution because you were working on that on your own. But here we're taking in 4 things. One is the age, one is how much that person weighs. The next is their heart rate. And then the amount of time that they're exercising. And what you're going to do is calculate how many calories they lose based on those 4 pieces of data. So the program up here gives you a calculation for how you figure that out. And you just take in those 4 values, use that calculation to figure out your answer, and print it to the screen so that your output looks like calories, format it to the right of the decimal, and then it prints the word calories. So here's your code for that. We take in, all these are integers, so they're converted to numbers, int. Number, line 11 is your formula. Let me just scroll over. Oh, that's the end of it right there. 8.368, there's nothing after that. On this formula, it is exactly what they have written up here, but you use your variable names, age, years, weight, pounds, heart, BPMs, and time in minutes. So you use your variable names and not these variables or these words that they have here, because of course you can't have spaces in variable names. But the formula is right there for you. You just calculate it out and print it, format it to the rate of the decimal, and there you go. All right, chapter 3 is on types. Let me see what questions. Does anyone have questions to start with chapter 3? Okay, the things with chapter 3 is it's talking about different data types of variables. So we have integers, floats, decimal values, and strings. And then we can create lists, tuples, sets, and dictionaries. And they're pretty common in other programming languages. Not everything has dictionaries, and everything has tuples. Or a list might be called an array in a different language. But it's the same concept where you can store multiple things in, one variable name, and then kind of, instead of creating a whole bunch of variables, you just use one variable to represent that. So the labs that we're doing for this one, 12, 14, 15, and 16. And each one of them has you working with a different type of data. So a list, and a tuple, and a dictionary, just your basic strings. And how to format that. So let's look at just two of them today. We will look at 312 and 314 today. I did not assign 313. You can skip that one. If you want to do it, you can, but you do not need to. So let's just for today look at 312 and 314, and then I'll give you time for you to work on the participation and challenge for those units, and let me know what other questions you have. So 312 looks like this. It's pretty basic. Here's your, I already have it coded. We have two input and formatting output, right facing arrow. This is pretty simple. We have two pieces of data we're taking in. One is your base character, and the other one is the pointer of the arrow. And then it's having you use strings to just print those out. So this is kind of a flashback to the first program we did in chapter 1, where we had to draw different things, like you had to draw an 8, you had to draw an arrow, you had to draw different things, and what we did for that is we just did a print statement, and then we would print it out in space. Oh, it was a block. I think that's what it was. Now we had to draw something like this. I'm not finishing my code. So what we did is we wrote it out line by line, but what this is showing you here is how you can use a list or a string of characters to store in a variable name called row 1 and then print those out for each one. So we're going to create row 1, 2, and 3. And it's going to, this is going to be row 1, this is going to be row 2, and this is going to be row 3. And then we're going to print those out in the form of an arrow. This is not something that you normally would do. It's not very efficient. It's just having you look at how characters, at how lists and arrays work. So our base character, when you run your program, this is what you would, your first character. So it's what do you want as the base of your arrow. So if I want an ampersand, then I'll put, or an @ sign, I'll put that, and then I'll hit enter. And then what do I want as the head of my arrow? Maybe I want a greater than sign. You can put, so this becomes the base character, this greater than sign becomes the head character. And then row 1 is a bunch of spaces plus the head character. Row 2 is a base, 2 heads, right? Because if you look here, we have all those bases, and then we have 2 heads, characters, more bases, 3 heads, and then line 4 is the same as line 2, line 5 is the same as line 1. So we print row 1, 2, 3, 2, 1. Put anything you want in your input, run the program, and you'll get different arrows. Kind of not a very useful or efficient program, but just looking at how things work. I would do that. You wouldn't really. Oh, I'm sorry, you're looking on Zoom. I don't even have my screen up there. You guys are way ahead of me. Are you looking on Zoom too? You guys in the classroom? Are you looking on Zoom too? Oh, you already have those done? You're working on your own stuff? All right. That's probably smart, because then you can do your screenshot right there or whatever.
Yeah.
A little bit more efficient than up here. All right, I don't assign 313 because I really don't like that program. That's another one that's not really efficient. So let's skip that one and look at 3. It's not required. So let's look at 314. This one isn't that hard. It's using the different operators, but I think it's confusing in asking and explaining what the program does. So I just think it doesn't explain what half-life is very well in caffeine and what you're trying to figure out. So you're writing a program that takes in the amount of caffeine that you're taking in, and it's in milligrams, and it's going to be a float. So when you enter in caffeine, it's caffeine equals float and then input. And that's so that you can say I'm taking 53.5 milligrams of caffeine. So that's your input. And then you're going to calculate and display to the screen what the half-life is of that caffeine after a certain amount of time. So after 6 hours, how much caffeine is left? After 12 hours, how much is left? And after 24 hours, how much is left in your body? And it does it based on half-life. So the way that this solution is presented right here is it calculates this and prints it out at the same time. So it doesn't have an input, a processing, and an output. It kind of makes more sense to do it that way. I mean, I would say, like, you could create a variable called after 6 and make that equal to the half-life right here. And then right here, you would just put after 6. This makes a little bit more sense, just to kind of clean it up. But the way they do it is they just calculate it and display it all in the same line. Because the dot, remember the colon dot 2F is for formatting to the right of the decimal. This other part right here is the formula. So we take in caffeine, if it's 100, after 6 hours, it's half the life. After 12 hours, it's a quarter of it. And then after 24 hours, it calculates that as well. So as a 16th of that. So the first one is you divide by 2, the second one you divide by 4, and the third one you divide by 16. That's why I say it's not very clear why are we dividing by 16, but it explains what the half-life is. So caffeine has a half-life of about 6 hours in humans. So after 6 hours, your caffeine level is half of what it was. And then after 12, it's a quarter of what it was. And then after 24, it's a 16th of what it was. So after a certain amount of time, it's completely out of your body. Then when you run it, you can plug in how much caffeine you took in. So if I took in 900 milligrams of caffeine, then I'm going to run my program. And I'll get after 6 hours, it's this, 12 hours, this, 24 hours, it jumps way down. Now, look at how I changed that. I created that new variable called after 6. I kind of like that a little bit better because then you can stick to your input, your processing, and output. But one solution, the first solution I showed you was this. I'll undo that in a minute. And whoops, this is duplicate. This was the first solution. And then I was just showing you, you could take out this formula and you could rate that into different variables. So this would be here after 12. I like this way a lot better. After 24. Then this way it's really more following our design where we do step 1 is our variables that we declare and our input. Step 2 is our calculation or our processing. And then step 3 is our output, and that's just our print statements and kind of what we've been following from the beginning with our programs, where we have some sort of input, some sort of calculation, some sort of output. And the way that the first solution just combined step 2 and 3. I like it a little bit more clear like this. Doesn't matter as long as you get the right, as long as your output matches, that's all that the program really tests for. It doesn't ensure that your syntax matches. There we go. So either way on that one will work. Any questions on that one? Okay. All right, and then the last lab was 315. Now there's not a lot of really new things in this program. We're not using any lists or tuples or anything. So maybe we'll look at some of the challenges as well. But here we go with this program. We're taking in two values. One is the price of a house right now. So my house right now is worth $350,000, and the price last month was worth $325,000. Then your program, when you run it, is going to find the difference and display that. So it says, and it's going to display it in this method where it says this house, the house value is 350, the change is 25,000, so it figures out the difference, and then it calculates the estimated monthly mortgage. So it takes two inputs and it figures out what the difference is between last month's value and this month's value. And then based on the current price of the house, it calculates the mortgage, and the estimated mortgage value is up here as current price times 0.051 divided by 12. And then it wants you to format it 2 to the right of the decimal, and then make sure your output matches this exactly, this format here. So here's a solution. Here's one solution anyway. We would take in our two values. We're taking them as integers, full numbers. We're making sure we convert to int so that they're not read as strings. I don't really like how they do the formula right inside of the print statement, but I'll not mess with this one. As I just showed you with the last lab, you can pull this out, and if you could call, well, I will show you because I like this better. I want to take out current price minus last month's price. I'm going to call that difference. And I'm going to, up here, after I do my input, I'm going to calculate difference as equal to what it was, current price minus last month's price. So it'll say the change is 25,000 or negative 10,000 or negative 1,000 or whatever the difference is. I don't need to format difference to 2 to the right of the decimal because those are whole numbers, because I'm just taking a whole number minus a whole number, so I won't get a decimal anyway. But when I go ahead and calculate the mortgage, which I could take this out too, and I'm going to, because I like it. I like taking the formula out of the print statement. It makes more sense, and it's really how code is done. It's not really put in the print statement. So I'm going to take the formula out of the print statement. I'm just going to copy it, Control X that, and I'm going to say, this is my mortgage. I'll just call it mortgage. And under the difference, I'm going to calculate the mortgage is equal to what they told me to make it as, the current price times 0.051 divided by 12. That's the price for the year, divided by 12 months. And then now my print statement is just real clear. I print out current price, I print out the difference, and I print out the mortgage. It's also a lot easier to not get lost this way when you're coding it this way, because there's less curly braces and commas and parentheses and just less things going on in the print statement. So you can see where it starts and ends. Let's throw in some different values, test it out. All right, let's go down to a $67,000 house and we'll change it around. So last month it was worth more. We'll say 84,000. Run the program. So now the difference is a negative value. The house is worth $67,000 this month. The change is $17,000 down from last month, and the estimated mortgage is $284. So there is that. Any questions on that one? I'm going to look at some of these challenges in chapter 3. What do I normally get questions on? Let me check my text and see if anyone sent anything. Okay, I don't have any, so let me just look at some of the strings should be okay, list should be okay, but let's take a look. The challenge activities. All right, let's look at challenge activity 322. This is on a list. We'll go through, when we look at chapter 3, it's broken apart into the major types of things that you can code. You can do strings, lists, tuples, sets, dictionaries. Strings are basic. We've worked with strings already, so I'm not going to look at the challenges on that. If you have questions, you can let me know, but let's look at the list one, which is 322. That's a challenge there. Where did reporting go? 3. Only 31% have finished it anyway. So list, functions, and methods. 322, that's the one we're going to look at. Okay, when we do these, these numbers change, and there's different values that come up. So my numbers might look different than your numbers, but the concepts are the same in each of the steps. So you start this by doing start. Well, what numbers do you have up on the first one? Just curious.
4.
4. All right, so like what I'm saying is if I refresh this, if I had 3, 4, 9, and 8 in that first list. If I refresh it, I'll get a different set of numbers. So yours will all be different too. And if you start it and then stop it and start it again, you'll get different values. But what they're asking you to do is the same. So here we start. What is the value of user, or what is the value in each of these spots is, I think, is what they're asking us to do. Whoops. What is the value? Oh, the value of length. Okay. So in step one, it's asking us what is the size of this? So as we read up earlier, there's a function called string.length, and it'll tell us the size of it, how many values it could store. So this stores 1, 2, 3, 4, 5, 6, 7. Mine stores 7 on this first one. That's the size of it. If yours has a different number, that's what it is. That's what the length is anyway. So then you check. Oh, mine just changed over on my other screen. And then it explains to you, this is kind of good. The string.length function len returns the number of elements in a list. So here's an example of a list called user ages. There are 7 numbers in that list, and it's all referenced with one variable name. That's the simplest form of an array, by the way. So we'll hit next. And now it wants us to, what expression changes user age to 77 and then 11? Is yours similar to that? All right, it looks like we're removing that middle number. So there's 2 functions in when we're working with lists. We can populate or remove, add one on or take one off. The thing that's going to try to trick you here is that the index value, which it's referenced as, this 77 is in spot 0, 55 is in spot 1, and 11 is spot 2. So it doesn't, when we count the elements of the array, the spots that they're in, it isn't 1, 2, 3, it's 0, 1, 2. It always starts at 0. So if I want to remove 55, that's in the 0, 1 spot. So I'll say user ages remove 1. Populate 1. Oh, it changes it to. Why does it want me to populate it? Pop removes the index at element 1. Let's go back. Let's go up and read that. Okay, pop 1 instead of remove. Oh, now I read the wrong number. Are you doing the same mistakes I am? Okay, now I got different numbers. Let me focus here. 99, 11, and 55. So I want to pop 0. Gotta read that. If we go up, there we go. If we go up a little bit, let's review pop. Not there. Pop and remove. So adding and removing lists from elements of the list. The trick thing is, again, it starts at 0, not at 1. So make sure you do that. Elements can be removed using the pop or remove methods. Append to add. Oh, here's the difference between pop and remove. Pop removes the element at index I from the list. Remove removes the first element whose value is a certain thing. Okay, that's a good distinction. I did not know that in Python. You guys understand that? So if it said list.remove 55, it would have searched it out and removed 55. But it said list.pop in that index and it took it away. So let's see if we get another one that asks about it. let's go on. All right, we have two lists, age 1 and 2. What expression creates this list? Basically the first list concatenated to the second list. It wouldn't be a sum because nothing's added together. So we're just concatenating or joining the first list with the second list. So that's the next one. Do you have the same type of question with different numbers for that one? Okay. What is returned by user ages in the index 4? User ages index dot 4. So 0, 1, 2, 3, 4. My number should be 4 returns the first index location of 4 in the list. The index location of 4. Oh, when it's hard brackets, it's the index number. When it is let's check this one. When it's 1, when it's curly brace or parentheses, it's the first index location of 1. Oh, okay, got it. Okay, so index whatever isn't saying what's in that list. It's saying where is that number in the list. So let me run it again. Okay, this is saying where is this one should return an error because 6 isn't. Oh, let me do it wrong and get a different value. Oh, it's something with a number. Okay, 7 isn't there either. I'm trying to get one. Now I just keep getting errors. I don't want the errors. Okay, it's saying what spot is 1 at? 0, 1. Kind of not very helpful though. Okay, here's one. What index is 8 at? So 0, 1, 2, 3. This user ages or the variable dot index in parentheses 8 will return the location of the number 8. And in here it's 0, 1, 2, 3. That's the location. Very good. And now sum is adding them up. So 7, 8, 9, that's mine. Yours will be different. So there's a lot of things you can do with lists. Sum's pretty handy. That's some basics with lists. Let's look at one of the challenges for tuples. Oh, tuples, which one should we look at? Challenge 322, probably. Okay, we're gonna look at 322, creating a named tuple. Tuples are a collection of data like a list, but it's immutable. Immutable means it cannot be changed. So the list that we just looked at, we could add to that, we could append, we could remove things, we could sum them up, we could do different things with that list, change it. But a tuple is immutable, which means you cannot change it once it's been initialized. A tuple is also a sequence type. It supports length, so you can do in the indexing things like what is the tuple dot length, what's the size of it. But once you have it, again, you can't change it. And each element of the tuple is separated by a comma. So it's the same process as list. But you initialize it at the beginning. So things that wouldn't change. So a good example are the coordinates of the White House, because that or any location of anything, it's not going to change. That would be, you could define that as a tuple. And you set the coordinates at the very beginning. And it's always the same. So you wouldn't change it. That's a good example of why you would use a tuple. There are things called named tuples, which is a collection of data. So you can have an object like a car, and then you can have a named tuple like car.price or car.color or car.cost, and those would be things that are associated with that car object, but it's represented as a tuple. It's called a named tuple. So this 322 or 332, excuse me, the challenge activity has you creating a named tuple. And they're just defined a little bit differently than what your regular tuples are defined. So the first challenge activity, this one up here, has you define a tuple or initialize a tuple with certain values, and you just plug those values in there, which would be these Rockets, Raptors, Warriors, and Celtics. This one has you creating a named tuple. A named tuple. Let me just check that syntax. Yep. Called player, and each element of that object player is associated with it: name, number, position, and team. So those are initiated at the beginning, and then you create different objects. So you create a Cam player and a LeBron player, and this is a way just to store bunches of data together with one variable name, and it's different data types. So that's one benefit of a tuple. Name and number, those are different data types that you wouldn't be able to store in other places. And imagine if you had an entire program and you wanted to store all the team players and all their data. Instead of creating a bunch of player objects like player 1, player 2, player 3, you create a collection of players, and then it's just represented as player. And then each one has its own name. So when we work with the Cam object, we're dealing with Cam Newton, and then LeBron James when we work with the LeBron object. So let me just make sure my syntax is correct here. All we're doing is initializing this named tuple at the beginning to store to store variables or values for name, number, position, and team. It's just asking, it doesn't give you a lot of information on tuples here. It's just asking you, how do you initialize a name tuple? And then the one before it is, how do you initialize a regular tuple? Not a ton of stuff. I don't usually get a lot of questions on sets. So I think we're gonna leave set basics. Let's look at the dictionary. I mean, we'll have lab time for next week, so we can cover some of these other labs. Next week. Okay, 351, that's a good one for, well, that will be the last one we cover, a dictionary. Challenge activity 351. It's not a lot going on in this program. We're just, okay, we've got, in fact, we can only type in that middle section there. So let's first look, what is a dictionary? And then you can add things to it. So a dictionary is a Python container that has a relationship, a dissociative or an associative relationship. What does that mean? Maps keys with values. Okay, so a key is a term that can be located in a dictionary, such as the word cat, and then the value, such as a definition of a cat. So it would give a name, and then what is that definition of that name? Keys are immutable, which we know means it can't change. But the description could change. So here's how you create one. Lionel Messi 10, so that would be like key 10 is going to store Lionel. Key 7 is going to store Cristiano. I don't know who those people are. Are they like soccer players maybe? Lionel, no idea. All right, and this is how you create one. What this is saying is how much caffeine is in each of these chocolate bars. So it's associating a number with a label. So in a Mr. Good bar, there's 122 milligrams. In a Red Bull, there's 33. I can't believe that's more in a Mr. Good bar than a Red Bull. In a Monster Hitman Sniper energy drink, there's 207 milligrams of caffeine. So it's creating one variable name, and it's storing a link between each thing, and then each thing is separated by a comma. So you can have 200 things in this dictionary, or 7 things like you have going on here. It's just that each of those things in there, notice how they're separated by a comma. So that when you then print it, and we're just printing one variable name, it's going to print all of that data, which is pretty cool. So what the program does is works with dictionaries. There's ways you can add, modify, and remove things from the dictionary using those pre-written functions. So those are explained there. Del for deleting an option of the dictionary. Modifying is done, and then adding a new entry is done this way. So in 535, it shows you how to do those 3 different things. All right, so what we want to do is modify and add in our challenge program. So we're going to write the program's already written that stores. It's a dictionary that stores the name of the car and where the car is made. So Acura in Japan, Fiat, Italy, and Tesla in the USA. So we want to write a program that adds the key Tesla with the value USA, and modifies the car maker Fiat to Italy, so that the sample output says this. So right now, I have a dictionary called car makers, and it says the Acura is with Japan and the Fiat is with Egypt. We want to change that so it's not Egypt, it's Italy, and we want to add the Tesla to the US. So the first thing we're going to do is we're going to say car makers Fiat. We're going to take Fiat and we're going to replace the value that Fiat points to, which is Egypt, with Italy. And then we're going to add a new item onto this dictionary called Tesla and point it to the USA. So when you run it now, you don't need any input. You run it, it'll pass and print out the new data. So this is how you print a dictionary. You just reference the first element of the dictionary. So car makers is the name of the dictionary. And then you say, I want to print where Acura is made, and I want to print where Fiat is made and where Tesla is made. So you have to reference each of those index to get the value that it points to. So we can add on to this dictionary just by, oh, I can't type up there, but you would just do comma and then single quote USA colon Tesla, for example. You can add on to those dictionaries. This chapter is not too hard. I don't think there's not major concepts in this chapter, but there's just working with different types of lists and data. So with that, I am going to stop talking and I'm going to stop the recording and just let me know if you have any individual questions. And I'll help you then. Thank you, everybody. Those on Zoom, you can get off whenever you want. I'm not going to cover anything else today. I will post this video if you need to reference something later.
Thank you, teacher.
Thank you. I hope you're doing better.
Thank you.
I hope it stops recording.